Hey everyone, I'm back again, just like Slim Shady. So I wanted to address some of the more difficult kinds of problems that were on the Khan Academy work. So the first two that I want to address with you are these two right here. We were looking for general solutions to differential equations, and I believe that these were actually in the find the error part, they were some of the hardest ones. But let's chat a little bit about them. So my first step here for this differential equation is going to be to factor an x out of each side so that I can begin to isolate my y's and my x's. So then when I do the algebraic manipulation here, I have y plus 2 to the negative 1 dy equals x dx. So I've isolated my x and y variables. So now I'm going to integrate each side here. The antiderivative of y plus 1 raised to the negative 1 power would be the natural logarithm of the absolute value of y plus 2. Keeping in mind that when I take a natural logarithm, I can only take a natural logarithm of positive values. Likewise, the antiderivative of x dx is x squared over 2 or 1/2 x, whichever way you want to write it. I'm going to tack on my plus c over here. So far, so good. This is my guess is that you all got this far. Then it started to get a little wild. And here's how it got wild. So I need to raise, I need to take each side to the base of e. So the base e of the natural logarithm of y plus 2 will just simply give me the absolute value of y plus 2. Then I have e raised to the x squared over 2 plus c. Now, this was the piece that I'm guessing is where many of you got tripped up. Think old school exponent rules. If I am adding my exponents, I am multiplying my bases. So I can think of this as e to the x squared over 2 times e to the c. Now, e raised to the c is just another constant. So let me just slide this over so you all can see it. Double check that I'm still in the viewing field here. Yep. All right. So e to the c is just another constant. So now I've got e raised to some constant, which will always give us a positive constant, c, times e to the x squared over 2. That's where that constant comes out in front. Now, I know that this is a positive constant, and e raised to any value is going to be a positive value as well. So at this point, I can drop my absolute value symbols and subtract 2 to completely isolate my y. I hope that helps. I think my guess is that where we're running into a problem is right there. So let's look at a second example that is going to have the same kind of thing going on in it. Give me just a second here to adjust this. My kids have become huge fans of Ultimate Beastmaster on Netflix. Highly recommended by the Blue Romano household. All right, anyway. So let's take a second and look at this second differential equation. We're going to factor out the y. When I factor out the y, I have 4x cubed minus 6x squared. And again, the reason I'm doing this is I have a differential equation that is in terms of both y and x, so I need to isolate them. So I have y to the negative first dy equals 4x cubed minus 6x squared dx. Now I'm ready to integrate. The antiderivative of y to the negative first is the natural logarithm of the absolute value of y. And then my Integral over here is going to be x to the 4th minus 2x cubed plus my constant c. Now, just as in our last example, I'm going to have to give each side a base of e to be able to isolate my y term here. So e raised to the natural logarithm of the absolute value of y is just going to give me the absolute value of y. Likewise, over here again, I'm going to kind of think of my exponent here in two chunks. So since I'm adding these two quantities in my exponent, I am multiplying those bases. So this is like saying e raised to the c, which is always going to give us a positive quantity, times e raised to the x to the 4th minus 2x cubed. Since these are always going to be positive quantities, I can drop my absolute value. E to the c is just another constant c. And there we have it. I hope that these are helping. I'm going to do 2 more Khan Academy videos, 2 more Khan Academy problems in just a minute to help you out with those. So, but I'm going to do them in separate videos so they're easier to upload. I hope this is helping, guys. Take care.